All right.
Let's see. Already there.
We are now live on YouTube. And I'm going to get our recording started back up again. All right, everybody. Welcome to week 9 of the Apple App Development course. I'm Michael. We have Taylor with us. And we're going to cover 2 main topics today. I still have a cough from being sick a few weeks ago, so bear with me. But we will get through it. This is the last class that we're going to have before we move on to working with
Swift UI.
So this is going to be kind of the last thing we have before we move on to actually writing the interface and things like that that we have been waiting for the class. All of these things, introduction to Xcode and all these things have been very important because we need this background to be able to we need this as background so that you know what we're doing.
Hey, Michael, you're not audible. You're talking to the air, Michael.
Did that fix it?
Yeah, now you have to repeat everything you just said.
Okay, that's fun. When I shared my screen, it turned off my microphone. Like I had to go press allow to use my microphone. So I've got Xcode running. Basically, everything that we needed to do, we have the background for. We're going to be covering classes and all those things. So we're going to start as we have been. There are so many different dialogues that Zoom comes up with these days. It's like, gets a little ridiculous. So classes, I even debated if we're going to talk about them or not, but they are very important for working with Swift. And also if you're coming from using UI kit and different packages there, it's very important. Give me just 1 second. I need to take care of one thing real quick. We had packages come in. I didn't want them sitting outside my door for the next 2 hours. So the with classes, remember we talked about structs last time. And a struct is a value-based object. They're very much more performant and faster with Swift compared to classes. Classes kind of came over from Objective-C, but structs are kind of the safe way to do data models and things like that in Swift. Now, the difference is classes you can inherit from another object and they're reference-based. So an example of of using a class in Swift is I may create a screen that's called a view controller. And that is the parent class. And then I'll create an instance of that class called, or a new version of that class that inherits from view controller and call it, let's call it main app screen. And it inherits from a view controller. Okay. Now, because I've inherited from a view controller, that's where classes are useful because it pulls all of its code from the parent class. That's where classes are useful. Structs, you cannot do that. Structs are basically every new thing is a new value or new object. Now we can have structs be copies of things. So like when we get into Swift UI, we'll talk about creating views. So basically every view we add is a copy of a parent view. We're not inheriting, so it makes it safer. Whereas with UIKit and AppKit, which is the way that we create things on the Mac, it's different. And that technique of using classes came from Objective-C. But we still use it on the UIKit and AppKit. Swift UI is the new way that we do app development. However, the previous methodologies are more performant, which means they work faster. So it all depends on how you want to build your apps. Swift UI takes up a lot less code, but UIKit and AppKit are faster. So if you wanted to use those techniques for building your apps, you would have to do that. Before we continue, do you guys have any questions before we get going? Feel free to raise your hand or unmute if you have any questions. Or any questions about previous content too.
I do have a quick question here.
Okay.
Sorry, I haven't been practicing or doing anything, so I have a basic question on my UI right now. Looks like I have my playground show up kind of like yours. You do have classes. I'm trying to create a folder similar to what you have off of my playground by right-clicking on it and try to create a folder. Is that what you have going here with classes? Or how do you get classes going on there? I might have lost it or something to that effect. I only have under my playground sources.
So what I do is I right click, or you could use the file menu, and I go down to new playground page, and that's how I create the classes page.
Thank you. That's all I need.
And I created a folder somehow. I don't remember what.
Yep, I think I can create folders underneath the new UI page. So that was what I was missing. Thank you so much.
Absolutely. Yeah, you could create folders under the new page. Yep. So yeah, just add new playground page and then you can do that. Okay. So a class, or does anybody have any other questions real quick?
This is Jad. I have a quick question.
Sure.
New to the class, so I don't know if you've already covered this. Is Swift like other languages where everything is an object under the hood?
That's a good question. I don't believe so.
Okay.
I don't believe that it works exactly that way. I have not looked that up though.
All right, thanks.
I think because I believe Swift can be used for functional and object-oriented programming. But I will actually look more into that because I'm kind of curious myself. But I do not believe that it is.
Okay, cool, thanks.
Okay. So let's talk about classes. A class is it's pretty easy to create in Swift. You can create a class by just using the word class. And so, for example, what we can do is we can say, let's define information about a user. Like say we have a user in our app. What we can do is we can say, and class is lowercase, so lowercase c a l a s s space user with a capital U, user space left brace, and this class is not inheriting from anything, so it's just a new class. And what we're going to do is we're going to give it two variables, and these are class variables. In Swift, class variables are scoped to the class. So we're going to say let UUID, which is let ID, sorry, equals UUID parentheses. So that basically says that this so this is a little bit different from a struct. So we're going to say let UUID or let ID equal colon UUID. And what that's going to do is we're saying that this class is a type, has a ID. And then we're going to say let name colon string with a capital S. And then classes typically have an init function. So we're going to say func init, and we're going to use, actually, no, it is not func. It is just init. So this will initiate an instance of the class. Name, so init left parentheses, name colon string. And I know this doesn't make sense just yet. And so we have init name colon string, and then space left brace. And then we're going to say self dot ID equals UUID, and then the parentheses. We talked about creating a UUID in structs. And then we're going to have self.name equals name. Okay. And what that's going to do is basically say that we could use this as data, and when we initiate it, we're basically using initializing variables. So we're creating a new ID for ID, and we're self.name equals name. Okay. So what we can then do is we can create, so typically all classes need an init function to set up the instance variables. And then we can have the class variables like we saw earlier. And then we can have functions as well. So we can have instance methods of a class that we can then work with. So let's call this function greet. And we're going to have it return a string. So we're going to have func greet left parentheses, right parentheses. It doesn't need an argument. And then we're going to do the arrow. So dash greater than space string with a capital S space left brace. And in our function, we're going to say return, because this is a return. It has to return a string. We're going to say hello space backslash parentheses name, right parentheses. Exclamation mark. It is great to meet you, period. Okay. So then we've created our actual class. So again, we have, let me get rid of some of this code that it created for us that we don't need. We have class user left brace, let ID colon UUID, let name colon string, init parentheses name colon string right parentheses, left brace, self.id equals UUID parentheses, so it creates an instance of the UUID, self.name equals name. Func greet and then we have parentheses, and I spelled greet wrong. Awesome. Greet parentheses space dash greater than string left brace, and then we return our string. Okay. Then after our class is over, you have two right braces. Make sure to use your indentions correctly. And you should be on line 18 if you are following on where I am. And then we can do, we need to create a new instance. We can say let first user equals user with a capital U parentheses name colon double quote Michael double quote right parentheses, and then we can say first user dot greet, and what that's going to do is it's going to run that greeting in the first user. Then we can say let second user equals user with a capital U because we're creating an instance of the user class, name, colon, double quote, Taylor, double quote, right parentheses, and then we can greet second user dot greet, and that will greet the second user. And then we can take advantage of the properties in each class. So I could then do something cool like this. I can say let names equals left bracket, so the left square bracket, first user dot name, comma, second user dot name, right bracket. Okay. Help if I use proper capitalizations here. Okay. So now I've created an array of our names. So I could then do something like print left parentheses, double quote, hello, backslash, parentheses, name, left bracket, 0, right bracket, right parentheses, space and, space, backslash, left parentheses, it's names, not name, backslash, parentheses, names, 1 in brackets, right parentheses, exclamation mark, double quote, right parentheses. And what that does is it'll say, hello, Michael and Taylor. Now, the question is, so why did we not get, we only got hello, Michael and Taylor. Well, why didn't we get the greetings? Because we didn't print them. We just said first name dot greet, or first user dot greet, second user dot greet. We didn't print them because they're just returns. So those kind of went into the air. So we would go back up to line 19 and say print left parentheses, and then we would just use first user dot greet in parentheses in the print statement. We don't have to put anything in string interpolation. And then we could do the same thing on line 21, print left parentheses, just encapsulate that line in the parentheses. And there we go. So now we have 3 lines. Hello, Michael. It is great to meet you. Hello, Taylor. It is great to meet you. Hello, Michael and Taylor. So you can see how we're using classes to build out functions and things in our code, and how we can use class instance variables to do more with that. This is an example of a class, and next I'm going to show inheritance, but does anybody have questions before we continue? Any questions? There was a question in chat. The videos are on the Techopolis YouTube channel. Okay, and we do have hands. So Fenton. Thought I saw hands up.
Sorry. Remind me on line 23 at the end, it has an exclamation mark next to the name of index 1. What's that about again? Why is the first name doesn't have it, the second one does have the exclamation?
Because it's the end of the sentence.
Oh, that was it? Okay.
Yep.
It's
Yep.
just a string. Okay.
Yep, it's just part of the string.
It's not a special character. Okay.
It's not being used as a force unwrap character. No, it's just part of the
Oh,
string.
okay. Yeah, I thought it was something else. Okay, thank you.
Yeah. Okay. Any other questions? Okay. So that is the basics for creating regular classes. Let's create we're going to create an inherited class. Let's you would not do it this way, but let's say you wanted to create another group of users that are super users. You would handle this very differently, but I'm just going to use it as an example here. So we're going to create a class, and we're going to call it, let's call it super users. Or super users. Colon, and we're going to inherit from the user class. User colon space user with a capital U, left brace. And so we're going to basically, the neat thing is that this works the same way. But now we can, I believe we can do something like let is admin bool, let is moderator, so is mod bool. And we're going to make these optionals because the user may not need to be these types. So init, and we're going to do left parentheses is admin bool question mark is mod bool. And we're going to do self dot is admin equals is admin from the init statement that we have, self dot is mod equals is mod from the argument from the init statement. Okay. So now what we're going to do is we're going to say we're going to create a function called func. You know what? Let's show overriding. So we're going to do an override func greet dash greater than. So we have parentheses dash greater than space string. So it looks just like our other greeting function. Okay. So what we're going to do now is return double quote hello \name, because remember this is inheriting from user. Hello \name. You are a let's see. We can do / is admin. We're going to use the ternary character. Is admin equals true, question mark. It wants to put super admin, but we're going to write just admin here. Double quote question colon space or regular user. And one of the things that we need to do if we're overriding this or doing this is we need to run super the super function. Which I think we need to do in the init function.
Can you say more about that, Michael? What do you mean we have to run the super function?
So we need to run what we have to do is when we create an inherited version of a class, we need to run a super a command called super. And any function that that you're running that you want to bring in the code from, you have to run what's called super. And this is done in Java and other languages. So what we would need to do is run super.init.
Oh, okay.
Left parentheses, name, colon, and I guess we would need the name let's see. I thought that it worked a little differently. Name colon string. This should come over from the but I guess that we do need to make sure that we have that. Super name colon name. Let's see if that's the way. Let me make sure the syntax of that, because I've used overridden classes, but creating one is a little different. So let me just verify the structure of that.
I have another syntax question too when you're ready.
Okay, go ahead.
Do you need to compare booleans to true or false, or do you just use the Boolean by itself.
You could just use the Boolean by itself.
Okay, because you were saying if is admin equal true, and I'm like, is that
Yeah, I don't know if you can do that with a ternary, like with the question mark. So I think you could do it either way.
Gotcha. Thanks.
But I just want to make sure that we have the right stuff here. So okay. Yeah, I was writing that correctly. So I'm not sure why it's giving me an error. Syntax is always tricky sometimes. So super.init and we want to still have the name in the init like we had before. And we're doing all of that correct. But I wonder if we need to put the super in the init at the end of the code. So let's try that at the end of the init statement. Yeah, I don't know why that matters. You have to use put in the init, the super.init at the end. So that's kind of interesting. So we have init name : string is admin : bool is mod : bool. So let's go down to let's see, like we were talking about, can we just use is admin admin and then let's do should be able to do is mod let's see, question mark mod double quote space colon double quote regular user. So we are now, if there wasn't errors, we would be checking, oh, we need a double quote. And what we need to do, because we're using optionals here, we need to, we're going to force unwrap this time. Actually, no, we do not want to force unwrap, because if we do and is admin or is mod is empty, well, we can actually force unwrap here because we will, well, we're just going to try it. We're going to force unwrap, and then we're just going to make sure we give values for each one. I'll tell you what, for this example, let's make these non-optional. Let's just make them regular so we don't have to force unwrap or do any of that kind of shenanigans. Let's see. It's saying that those are now optionals, even though they're not. So we're going to give these default values here. So after, in the init, we're going to have self.isAdmin equals isAdmin question mark false. And we're going to do the same thing on the next line, question mark false. So if these are not assigned, then they're just going to be false. So now we can definitively say we don't need the exclamation marks here and here on line 80. What is that? 30 with our where we're returning, or 31, excuse me. Well, we're returning hello name. You are either admin, moderator, or regular user. Okay, so let's make we're going to go down here to line 40, and we're going to say let admin user equals let's see, what if we call our class again? We called it super users. Which it should have been singular. So let's fix that. So we're going to go up here to line 18 and change super users to super user, because that should be a singular use of the word. So we're going to go back down here to the bottom. Let admin user equals super user, left parentheses, type name, colon, space, double quote. I'll just recycle names here. Michael, double quote, right, comma, is admin true, right parentheses. Oops, I do not know why I used capital T. I guess I was thinking in Python. Okay. And because we did not declare them as optionals, we need to put 1, comma. So is mod colon false. And that should keep capitalizing these. I guess I'm thinking Python today, guys. I capitalize the F in false, and it's a lowercase in Swift. Okay. So let's use print, left parentheses, admin user dot greet, and parentheses, and then close your parentheses. So we have, hello, Michael, you are a admin. Should have been an admin. So now let's do let mod user equals super user, left parentheses, name, colon, space, double quote, Taylor, double quote, comma, is admin, colon, false, comma, is mod colon, true, right parentheses. Now, let's do the same thing. Print mod user.greet. So now we have, hello Taylor, you are a mod. Okay. Now let's do a third one. Let regular user equals super users. Super user, parentheses, name, colon, double quote, space, double quote, Becky. Picking on Becky since she's not here. Comma, double quote, is admin. Why isn't working? Colon. What's going on here? I didn't capitalize the U, so my auto completion is not working. So I'll fix that. Is admin false, comma, is mod false. Okay. And we're going to go to the next line. And we're going to do the greet. So print regular user.greet. And hello, Becky. You are a regular user. Now, here's what's neat about that. We're doing all this stuff, and we did all of that on one line because we used the ternary character. So we didn't have to put an if statement or case or any of that stuff. So you've just now seen a real world use of the ternary character. And that really, really does help on your conditionals. And you can do that in a lot of places in Swift. So this is kind of how far we're going to go on creating classes today. Do y'all have any questions on that? All right. Any questions? I know that there was quite a bit of stuff. Okay, let's see. Fenton.
I guess I don't quite understand those overrides that you put in place.
Okay, I will explain that a little further. So, what the override does, we have a function in the parent function called greet, right? So, to have our own function in this version of the class called greet, we have to override the parent function. Now, what I can also do is I can say, well, actually, we can't do that. I was going to say we can add a super, but then we'd have two return statements. So that would not work because of how the first function was written. So what we can do is, let's see if this works. We're experimenting here, folks. So I'm going to go back up to the first greet function in user. And we're going to say, I guess that would not, because we have two return statements. So we could not use an well, Yeah, we could not. That would be interesting. So basically, because we have two return statements, using super in this function would not work. So what we would have to do is we would have to make one not have a return. That would be changing a lot of code. So let's do something else. Let's write func. And let's say print name. Or let's see, what's something that we can return? Let's say print name, and we're going to then say space left brace print left parentheses name. Okay, so now we're going to change the name from print name to print data or print user. Let's do that. Print user. Okay. So in this first instance method, we are printing the user's name. Okay. So in our next function, let me just get rid of this new line character here. We're going to say override func print user, and then we're going to call super dot print user, and so that's going to print the current user like we had before, but now it's going to we're going to say print user print parentheses is, let's see, is mod or is admin question mark double quote admin double quote colon is mod is mod question mark double quote mod double quote colon double quote regular user or regular. Okay, so we have that that we're going to print. So when we print user, it's going to print the name and then their status. So let's do one more. We're going to do let another regular user equals, so let another regular user equals super user parentheses name colon double quote let's see, who do we pick? We'll pick on Lauren because I don't know if she's here. Lauren double quote comma is admin colon false comma is mod colon true. Why do I keep thinking in Python? Okay, I did write it right. Okay, right parentheses. And then we're going to use another regular user dot print user. And what that's going to do at the bottom, it's going to say Lauren and then mod. So it printed because it was called in super, in that super dot print user. We print the name, and then in the new version of print user, we are printing their access level. So that's how we are overriding the data there. Okay. Any other questions? So we did a regular class, and then we did inheritance.
Yeah, Margaret, you have the question.
Sure.
I got knocked off of Zoom, and also some of this stuff I'm gonna have to go through because I'm not getting all on the screen. I'm getting as much as I can, but I'll get with the pics and the notes. But did we do overriding, or did I forget that, or did I miss
No,
that?
this is all new for today.
What
Overriding.
does that mean,
is-
overrating?
So again, overriding is, say I've created a so let me put this into a different perspective. Overriding is like when we talked in the beginning of class, and we had a say we're building an app the way that you used to. When you load a screen of your app, it runs what's called view did load. Okay. And so all of the code that happens whenever your screen loads runs. And that's an instance method of the view controller class. And then
Okay.
we override it, say when our view loads, here's the interface that we want to have here. So we're overriding the parent's version of view did load. And in this case, we're overwriting the original, and we're using super to add the code that was originally there. And then we are using inheritance and then putting our own code. Think about, here's another way to put it. Think of a person, think of human as the parent class, okay? Then we have each of us as an inherited person in the human class, right? We are all instances of a human class. We all have the same instance methods of human, but we also have our own instance methods. Like I may have instance methods of programming. I may have my own instance methods that the parent doesn't have, but I override from the parent. Like I have my own ability to talk. I'm overriding from the bigger, class of human. Classes have properties and functions. Like name and UUID are properties of the class. And each class has its own properties. Then when we created our own inherited class, when we did that, what we did is we added more properties. So the is admin and is mod are two properties that we've added on the child version of the class.
Okay.
And object-oriented programming is a lot, guys. Like we could spend hours and hours and hours talking about this, but this is just a few examples of how we can use classes. And if you remember when we worked on structs, you could do a very similar thing, but with a lot less code. This is why there are times where we have to use classes, but they aren't as in Swift UI, they are not as used as a struct. Okay.
Hey, thank you. Thank you.
Absolutely. Okay. Any other questions about classes before we move on? Okay. And Fenton.
Well, is UUID a key name or something like that? Must you use the word UUID for something?
So
What is
UUID is a
UUID
type. UUID is a unique identifier type.
type? Oh.
In other languages, you
What
can
do you
think
get
as
out of it?
what's that?
What do you get out of it by typing the word UUID?
So what you get is, well, for one thing, it's a type, just like a string or anything like that. But when we assign something as a UUID, we're basically saying this variable has a unique identifier, and we really don't care what it is.
Is this self-generated? Once you
Yes.
use that type?
Yep. Swift generates it.
Randomly generated.
Yes. Mm-hmm.
And would we expect it to have a 16 byte, uh, 8 bytes, or 64 bytes? What kind of generation are we expecting out of it?
Well, let's find out, shall we? So in our print user, actually, let's put it up in the uninherited one. Let's see, print user. So we have print name. We're going to do print ID. Okay. So now when we look down here, we have Lauren C288C8897 dash blah blah blah. It's a very long ID. And then after that,
Alphanumeric then.
it's hexadecimal, I believe.
A hex. Oh,
How many hex digits, Michael?
There's a lot. There's 8, then a dash, then 4, a dash, then 4, a dash, then 4, a dash, then looks like another 8. They're pretty long.
It's 14 bytes.
Yep.
looks
Wow.
like the last one is more than 8 though.
Yeah, it is. Wow. They're long UUIDs.
12. Looks like the last one is 12.
16 bytes. Okay.
Well, it's 8 and then 12 and then 2 groups of 4. 3 groups of 4.
So that's the format to be expected then at all times with the UID.
For UUIDs. Yep.
Is there any other ID that we could select from besides UID as a type?
Not that I'm aware
If you
of.
want something, self-generated.
I mean, you could basically use an integer or anything that you wanted to self-generate, like that you wanted to create, but this is the only one I know of.
Okay, self-generated, so you don't have to worry about it at all.
Right.
Okay, got it. Thank you.
And these are used even in when we get to talking about Swift data, we use these in Swift data all the time for basically database keys. Okay. So this file will be going on our platform in the class. And so now we're going to go on to concurrency. Okay. So a lot of times our apps need to be able to run. We use most applications run on what's called the main thread. Threading is a very commonplace thing in most programming languages. A lot of them have different ways of holding execution, but they all have different ways of doing it. Swift now has a modern async await methodology for using concurrency. We used to use what was called Grand Central Dispatch or GCD, and we would create our own threads. Basically, Swift concurrency helps us do work at the same time without freezing the user interface. So why it matters for iOS apps, many tasks can be slow. And these can include network tasks, loading files, database access, image video processing, or AI calls. If you do those on the main thread, the main execution of your app can become unresponsive or slow. Swift concurrency gives us a modern way to look at this. Tools can include run work asynchronously, keep user interface responsive, so keep the UI moving while we're doing background tasks, and avoid what are called race conditions. So the first thing that we'll talk about is async await. And this is the core idea behind this. Instead of, messy callbacks, which JavaScript used to use callbacks and a lot of languages did. So when this is done, do this. And you had to nest those. We can write asynchronous code like we're going to try here. So we could, we could have let's try to write this in a way that the compiler won't throw anything. So we're going to write func download data, and we're going to return a string. So func download data, 2 parentheses, no arguments are needed, dash greater than string as a return. And we're going to return double quote data received. So this is just kind of a simulated, we're trying to download data. And I apparently can't spell. Okay. So now we're going to say let data equals try await download data. So it's complaining because we're not using, let's see. Nope, I tried to fool it. So I have func download data parentheses async dash greater than string. So we're saying that this is an async function. And so I took out the try. So we have let data equals await download data. So basically that kind of runs this on a different thread. It downloads the data on a different thread. So then we can do print data. And so that kind of simulates like we it kind of simulates that. But we get an error because we're not properly executing that correctly. But that's kind of how you write it. It's we're downloading the data and things like that. So let's actually create one. So let's create a function called fetch greeting. So we're going to get rid of the code we have here because this is a bit better of a function. Fetch greeting, parentheses, async dash greater than. Okay. Oops, I needed to put string space left brace. And then what we're going to do is we will write some code in here. So we're going to tell it to sleep. So we're going to write try. Try question mark await task dot sleep. So we're just saying 0.0 nanoseconds, and we're going to tell it to sleep for 1,000 seconds. And then we'll return return double quote hello from an async function double quote. And so now we're going to write outside the function, we're going to write task to create an asynchronous task, space left brace. And then we're going to say let greeting equals await fetch greeting. Kind of like what we did earlier. Let greeting equals await fetch greeting. And then we're going to say print greeting. Okay. So what this is going to do, so what does task do? It's a task starts an asynchronous unit of work that can run at the same time as other tasks. Now, what that means is that sleep command, our program is going to continue to execute, but the task, so when we have task left brace, let greeting equals await fetch greeting, we're saying run that on a different thread. And then once it's done, print greeting. Okay. So this makes sure that this fetch greeting runs on a different thread. So this is basic async await. And even I will probably refer back to this whenever I need to really see how this works, because it is a little confusing how to write this. But basically we're saying we've created a function that runs on a different thread. Okay. Any questions about this basic structure? All right, Fenton.
Mhm. You mentioned the basic structure. The whole frame that you have used with the function that has the keyword async, is that the beginning of a new thread by saying the word async? And then must we use the await at all, or is it just an option because of this example? Is async the way to create a new thread, I suppose? Yeah.
Async because it's in our function declaration. Func fetch greeting async. Async is saying that this should be ran on a different thread.
Okay.
Because if I were to remove await down here, we get an error in our code that says expression is async but is not marked with await. Now let's see what happens if we completely remove our task block. And it still does not like that. And let's see if we add await back. What happens there? So that actually works. That runs. But the task is what puts it into a different thread.
And that thread is named fetch greeting.
Actually, believe it or not, because we don't have a task, it is erroring. It says error execution stopped with unexpected state. Error execution was interrupted. The process has been left at the point where it was interrupted. Use thread return X to return to the state before a bunch of useless stuff there. But if we add the task space left brace, and then we use the right brace after that's done, then what we get is hello from an async function. Okay. So basically it sleeps for a second and then returns.
I typed much the same thing, but I didn't get that result. Maybe I have not run it yet. Maybe I should try running it.
Do you have your debug console showing?
It's showing the previous class.
Yeah, I'm seeing that
Page.
too, but after mod, after the UUID, it says hello from an async function.
Oh, yeah, I got that too now.
Yep.
Maybe I clicked the focus back to concurrency. I don't know. Yeah, I got the exact same thing that you have now.
Great.
So the async is to create a new thread, and the
No,
task is to associate back to that
async
task.
says that this should be ran on a new thread. Task is to create kind of that new thread.
Oh, okay. Okay.
Okay.
Thanks.
All right. Are you guys ready to move on, or do y'all have any other questions?
I guess I have one more question. So we we can create as many threads as we want them? Are there any limitations?
There's not many limitations. You can create a lot of threads. You want to make sure that your threads are, after they're used, you get rid of them. And it typically does that when the code blocks are finished running.
How do you track which is that particular thread you're running? Let's say I
So
create 2 threads.
in Xcode, there is a navigator where you can see what threads are running. And again, you only want to have a thread used when you need to do something in the background, like downloading data from the internet or doing things like that. You don't want to keep a thread going indefinitely.
Can you ask the thread to close?
No, typically threads are closed whenever they're done. Like when the task block is done.
Oh,
So after
it
the
just
print statement, the
disappears.
thread is removed.
It's removed.
Does that make sense?
Not quite yet, because let's say if my thread takes longer than a few seconds to run, and the other one takes another few seconds to run, could they run simultaneously? And how do you keep
Absolutely.
track? Can you
Yep.
keep track of those?
Your app will keep track of those.
Apple does that?
Yes, Apple keeps track of your threads. And as long as it doesn't take up too much memory on the processor, and you can monitor that in Xcode, then your app will be fine. The one thing you don't want to do though is update the user interface on a thread that is not the main thread.
Or there's a main thread and a sub-thread somehow?
The main thread is where your user interface updates. Everything that we've created here are sub threads. We don't really have to worry about it because like our print statements are just being printed to the console. But if we're updating UI, then we don't want to update on the main. We want to update on the main thread.
And this is obviously for performance, right? If you have multiple threads, it's faster than linear execution.
Correct. Correct.
All right. So it would be kind of interesting to kind of track it. You said the navigator tells you when
They're one of the
threads are run?
navigators, yes.
Okay. Thanks.
Okay. So we also have what are called actors. And what actors are is they're kind of like objects. And what you can do, so I want to just write this and then we'll talk about it. So we're going to create an actor. And what we're going to do is we're going to call this actor we're going to make a score storing center. So we're going to call it score with a capital S, store. And then what we're going to do is we're going to create a score variable of 0. We're going to make it private. Score equals 0. Then what we're going to do is we're going to create an add function. Func add. And what we're going to do is points colon int as the argument. Right parentheses, left brace. And we're going to say score space plus equals points. Then we're going to say func get score, and we're going to return the score. And we're going to return an int, no arguments. And apparently, instead of writing return, you can just write score, which is an interesting way. Had an error up at the top. Okay. So we have score, we have add, and then get for these functions. So now we're going to create an instance of this. So we're going to say let score equals let store. What are we going to call it? Let store equals score store, and then parentheses. So these are kind of like structs, by the way. Let store equals score store parentheses. Okay. And then we're going to create a task like we did before. Task left brace. And what we're going to do in our task is await store.add points 10. Await store.add parentheses points colon 10 parentheses. And then what we're going to do is let current, which is our current score, let current equals store, nope, await await store dot get score parentheses. So we've assigned a variable of current to our current score. And then we can print current. Print left parentheses current. Then we can say await store dot add and then parentheses points colon 30. So we now should have 40 points, or what I write? Yeah, 40 points. And then let current equals await dot store, or not await dot, await space store dot get score. print, parentheses, current. No, error. And I needed to change let to var for current. Now that's interesting. So, what happened here? Why do we have hello from an async function after 10 and 40? Does anybody have any ideas? The code for 10 and 40 happens after the other. It happens after we are trying to print hello from an async function. Why in the world would that be? Why does the original code for print greeting show up after our scores? Anybody can unmute if you think you have the answer. I did not intend this, by the way. This is kind of cool.
I'm guessing perhaps computation is faster than printing.
Close. Any other guesses?
Could we tell how much faster we're talking about here with milliseconds printed somehow?
Well, we can, but it's a lot more common sense than that. Any other guesses? Becky, Taylor? Any other thoughts? Evelyn, what's your guess?
Because you need data to be able to print, have variables, information. Because
You're right.
if you don't have that, you can't print anything,
You're right.
right?
But we're looking at concurrency here. So does anybody know why the scores come up faster than
Because you
the
have functions
nope,
that store data,
nope,
memory.
nope. Okay. Fenton.
Because we put a weight of sleep time earlier?
You got it. You got it. Because our scores are taking faster to calculate than it is for that 1 second to then show the data. Because we're running all of this in concurrency. So all these are all happening on separate threads. So our program is not waiting to do a thing. It's just saying, well, this 1 second task is too slow. I'm working on this other thread over here. I'll just calculate those scores, and then you'll have to catch up whenever you get done. That's the power of concurrency that we accidentally saw in our code. Pretty cool, huh? All right. Any questions about concurrency? There is a lot more to that. During Swift UI, we're going to talk about main actor. But that is a really neat way to code. because what we're basically doing, creating our own actors, is we are able to say, that actor running that code, it's kind of like a struct. And so because we're using an actor, a custom actor, we are able to run that on its own thread. Using actors and things like that make code safe to share when going between tasks. It also gives a lot of errors at compile time if you don't do something right. And again, there's a lot more to this, but that is some very basic concurrency. Classes are a little bit more tricky in compared to actors, because when you use a class in concurrency, they can be shared and changed if you work with multiple tasks. So that's why we use actors and structs. So that's going to be our main, that's going to be our main stuff for today. Do y'all have any questions about all of this?
Early on, I raised my hand, but it was not noticed. So pardon me that I'm just
Oh
gonna
no, go ahead. Go ahead.
chime in. Couple of things. One is, could you explain to me about a private variable, why it could be called from a different function that I thought it was locally, the variable was local. So how could we be calling a score from a different function, I guess?
Because you may
So
have different,
weird.
you may have multiple of the same task of the same actor. So you want to make sure that it's private to that specific call, to that actor.
If you didn't put private, is that treated globally, or what's the deal there?
I think what would happen is that if you had multiple of the same threads, it may get confused as to what version of that variable to work with. That's my guess.
Second question is, could you define what the word actor means?
Sure. So actors are kind of, you could think of them as your representation of threads. You can name your threads. So like main actor is the main thread, right? But with this, we're creating our own actors, our own threads. And each
How many
time,
actors are here in your code right now?
basically two. Now, in our code, we could technically create multiple actors of the same, so like where we have let store equals score store, we could say let store one equals score store score store, and that would create another actor. So then I could go down here and make another task left brace, and then I could do await store one dot add parentheses points, colon 80. So do you see what we're doing? We created another actor, another instance of the actor based on that score store actor. So we have store and store one.
Yeah, I saw the two instances of the actor.
Mm-hmm. So like you could do let red team equal score store, let blue team equal score store. And then in each task, you could, and actually that would be a very good use of this here. You could be changing the scores for each team with score store actors. And therefore, those could be changing. Actually, that's a beautiful way to look at it. Those would both be changing in your app on different threads. Let's do that, actually. We're going to change these names, so it's going to error a lot. Let's change it to red team. Oops. Red team. And we're going to change the second one to blue team. And it's going to have a bunch of errors. So I'm just going to replace all of the store references. And there we go. So now in the second task, we'll change that to blue team. And then we'll do let current equals await blue team dot get score print current. Okay. So then we are now tracking in different threads the status of both teams as the game goes on. Does that make sense?
Yes.
So then what we can do, there's technically a way, I'm not going to do it today, but and this might be homework. There's technically a way where you could then create another actor or something else to track these both. And so you could technically print out after the game is over which team won. So that might be a fun little exercise if you want to try that. So that would be like nesting or figuring out how to get the threads to actually show the results. So this is concurrency. This is running things at the same time in our app. Okay.
Must you create a function of a thread, or can you create a thread without the function?
Yeah, I think you would need to have functions for your await and your async stuff. Evelyn, you have your hand raised, or was that from earlier?
It was from earlier. Sorry.
Okay, no problem. Okay,
Yeah. I've been busy, so I've been in and out of them.
no problem. Okay, any other questions before we go and wrap up today? Well, folks, you guys are ready. Swift UI will start next week, week 10. So we're getting to the really fun part of this class. So I'm really excited to work with you guys on that. It's going to be a great class. I'm going to have the notes up for this week right after this. So stay tuned for that. And we are going to start on Swift UI. It won't be nearly as hard as what we just went through today. This is kind of the most difficult part of Swift, in my opinion. So, good job, folks. There will be office hours, I'm sure, at some point soon, and we will keep you updated on that. And I think this was a good class. Taylor, do you have any final thoughts before we wrap up?
Yes, I do. A couple announcements from my side. So I've heard numerous bits of feedback from students that they also prefer the same content written in kind of a like text-based kind of book style. I did try this with week 8 so that you get everything that is from week 8 in kind of that style, so you won't be missing out on like the bullet points. I am seeking feedback on that, so please let me know what you guys think about that. You could just comment on the notes. If something's wrong about it, let me know, but I'm hoping that that will help people who learn best by text.
All right.
And I think that's it.
Thank you, Taylor. Okay. All right, folks, we will see you all next week. And I hope everybody's having a good new year, and we'll see you all soon.
Thank you.